All right, 5.3 has to do with binomial random variables. When the same process is repeated several times, we're often interested in how many times a particular outcome occurs. All right, and this is what creates a binomial setting. It arises when we perform several independent trials, that's a key part of binomial, of the same chance process and record the number of times that a particular outcome, called a success, that occurs. So there's 4 conditions for a binomial setting. They are, and they spell out the word BINS. B is for binary, meaning the possible outcomes of each trial can be classified as a success or a failure. There's no in between, just success or failure. 2 outcomes. I is for independent. The trials are independent, that is, knowing that the result of one trial does not tell us anything about the result of any other trial. It doesn't affect the others. N is for the number of trials of the chance process must be fixed in advance. Like we know going in we're going to do this 10 times or 5 times. It's not we do it until something, we do it 5 times, 10 times. And then S is for success. There's the same probability of a success for each trial. All right, and that goes hand in hand with being independent. But those are the 4 criteria: binary, independent, number, and success. All 4 of those. So pause the video, write those down. When checking the binary condition, note that there can be more than 2 possible outcomes per trial. In a pop quiz activity, each trial had 5 possible answer choices, A, B, C, D, or E. If we define a success as guessing the correct answer to a question, then failure occurs when the student guesses any of the 4 incorrect. A binomial random variable. The count of successes x in a binomial setting is a binomial random variable when the possible values are 0, 1, 2, 3, and whatever the number of trials is. If it's a 5-question test, it would go from 0 to 5. 10 trials, it would go 0 to 10. That's how many possible successes we could have. That is the binomial random variable. What does the probability distribution of a binomial random variable look like? Okay, the distribution of a binomial random variable is a binomial distribution. That's the name. Any binomial distribution is completely specified by 2 numbers: the number of trials of the process and the probability of that process. Okay, so X is the number of children with type O blood. The binomial distribution with N equals 5 children, and P equals 0.25, chance that they have O blood, has a clear right skewed shape. So these are the probabilities that 0 have type O blood, 1 has type O blood, 2 has type O blood, 3 and 4 and 5. And so when we draw a histogram of that, remember along the vertical axis is the probabilities that go with each possibility. So you will be doing a distribution, and I'm going to show you how to find each of these probabilities, and then you can draw your histogram from that. All right, so first type of question you're going to encounter. Determine whether the scenario describes a binomial setting. Justify your answer. So here's the scenario. Biologists estimate that a randomly selected baby elk has a 44% chance of surviving to adulthood. Assume this estimate is correct. Suppose that researchers choose 7 baby elk at random to monitor. Let X equal the number that survived to childhood. So we got to decide, is it binomial? So we take it through the BINS checklist. Okay, the first thing, is it binary? Okay, is it a success or failure? Yeah, a success is that a baby elk survives to adulthood. A failure is that a baby elk does not survive. All right, next thing is it independent? Knowing whether or not one randomly selected elk survives tells you nothing about whether another randomly selected elk survives. Okay, so survival is independent between the elks. The number, how many elk did we choose? We chose 7. And the probability, does it have the same probability of survival? Well, it says each baby elk has a 44% chance. So yes, it has the same probability. So you're going to be asked to take a scenario and run it through those 4 checks. If they don't have all 4 checks, it's not binomial. If they do, then you're good to go. All right, so now the next part of the question says, okay, biologists estimate that a randomly selected baby elk has a 44% chance of survival. We chose 7, same thing we talked about previously. So X is the number that survived. So here's the real question. Find the probability that exactly 4 of the baby elk survive. So that's 4 out of the 7. So the formula says, or we write it like this, probability that X equals 4. Well, there's 7, I chose 4. Probability of survival is 0.44, and those are the 4 I chose. So the complement of that is 1 minus 0.44. And then this is the other 3. So I chose 7, so 4 plus 3 makes 7. And then I get this value. Now, I know you're not going to use this formula. Pause the video and write down these keystrokes, and I'm going to show you how you're going to input this information into your calculator. All right, on your calculator, you're going to follow these keystrokes. You're going to hit second and vars, which is right there between program and clear. You're going to get a whole list of distributions. And you're going to actually go up arrow, and you're going to look for binomial PDF. Okay, A, binomial PDF. Hit enter, and it's going to ask you, okay, how many trials? Well, we chose 7 baby elk. P is for what's the probability. In this case, it's the probability of survival, so we put 0.44. X value is how many do we think will survive? Well, we're looking to see the probability that 4 survive. So we put a 4 there. Hit enter, enter, enter one more time, and there it is. There is our probability, 0.2304. Okay, that's where they got this value right here. Now, what you need to write down for me is this information right here. What you need to express to me on your paper is that you tell me what the trials were, what is P and what is X, and that you use binomial PDF, okay? There is a time for CDF, but right now we're just doing PDF. This is what you must write down, okay? Next part of the question, same scenario with the baby elk, all right? The question says, make a histogram of the probability distribution of X. Describe its shape, okay? So the first thing you have to do is make a table of all the probabilities, okay? We had 7 elk. So 0 survived, 1 survived, 2 survived, 3 survived, 4 survived, 5, 6, and 7, okay? Now we have to figure out these probabilities. Well, that's what I just showed you how to do in the calculator. On the previous slide, I showed you how to find where X is 4, okay? So you're going to use your calculator, same keystrokes, and you're going to do, it's going to be trials is always 7, the p-value is always 0.4, and X, you're going to change it. You're going to do 0 first, then you're going to go back and do 1, then 2, and 3, and 4, all the way till you've completed all these different probabilities. You've done it right again if you add them up and they add up to 1. Okay, so you're just going to use that function on your calculator to complete the table. Once you've done that, then you can draw the histogram. Remember that the top row, that's what goes on the x-axis. The probabilities go down the y-axis. Make sure you label and draw the bars to their relative frequencies, the probabilities that they correspond to, okay? Then that's part 2. Part 3 says to describe a shape, okay? So it doesn't have to be a huge paragraph. You're just going to tell me, you know, this graph is fairly symmetric with a single peak at x equals 3. That's all you'd have to tell me to describe your histogram. But it is a loaded question. You have to make a table, you have to complete the table, and you got to describe the shape. But you're capable of doing all of it. All right? We'll see you in class.